Alright, so welcome back everyone. And today, this lesson we're going to talk about properties of timber. And I'm your teacher Quincy Lester. Yeah, as you guys would have known me from school already. But for those who don't, yes, I'm Quincy Lester. So you ready? Let's begin. So first let's start off with an introductory video. So there you just watched that video on um, speaking about what we're going to talk about. The characteristics are the properties of timber. So it covered on a few stuff we're going to speak on today. And at the end of the video I may just show it again just to recap what we did. So our objectives: list the properties of timber, explain each property, give examples of the various properties. So the properties of timber. Timber, like many other materials, or to specify building materials also, have several characteristics that define their structure, look, and composition. They speak to how they're built, how they may appear, and what makes them up. These are known as properties or features. Some properties that we will look at include grain direction, texture, color, weight, Strength and durability. So here we go. Grain direction. So the grain of the wood is used to describe the cells and their direction in the timber. There are many types of grain direction types. These include, there are several types rather. Straight, spiral, interlocked, and wavy. So the grain of the wood tells how this tells about the cells and the direction that the cells are placed or allocated in the wood. So go talk about the straight grain direction. So this denotes species which grow straight and parallel with the tree's trunks. So you're talking about cells that grow parallel with the direction of the tree's trunks. Spiral, this speaks that some trees grow with the grain at a slight incline with a spiral-like pattern circling the trunk. You ever notice on some wood that when you see it, you see like this spiral looking curly thing in the lines. So the grains are like in the cut wood would be like those lines that you see in the wood. That we'd see in all woods. It could even be a mopstick. If you take up a mopstick, you look, you probably see some lines running from top to bottom. Or your table, or your chair, or your dresser, or pretty much anything that is made from wood. Your cupboards, you look and you see the lines and those would be the grain direction. So spiral now wood where you see those lines with an incline, a slight incline that looks like a spiral. You see this is going to come like swirly. You turn up like the line, following the line and then it turns up and makes it smile. That would be the spiral. Interlock grains now occur when spiral grains change direction and spiral back. So interlock is when you have a spiral and it changes direction and spiral back through the trunk, alternating between right hand and left hand spiral. So in other words, so it's like it going up, the spiral going in one direction, it's going up, and then you just change direction and come back down. So you're making, so the spiral changes and comes back down instead of actually finishing the line. There are some where you follow along the grain straight out to the end, and there are some that just change direction and comes back. And wavy, just as the name implies, this grain pattern indicates when the grain of the wood grows in a wavy fashion. I was about to say passion. Fashion. So now we'll move on to texture. And what does texture speak about? It speaks specifically to the feel of the timber. So texture is basically self-explanatory. It's how the wood feels. And you have three classifications of that. You have fine, which is very smooth and glassy. Medium, which is not too smooth nor too rough as coarse wood. And coarse, which is somewhat soft and rough. So it's how the timber feels. And we move on to color. So the color of the timber relates to the heartwood of the species. And we spoke about heartwood in the last video. We spoke about it being directly after the pith. Like that. The center rings directly after the pith inside the tree. And most timbers vary in color and will change with use. And will change with use, the application of finishes, and the exposure to light. So what this is saying that timbers have different colors, and based on how it is used, the different finishes such as paint, varnish, stain, or even the exposure to light or sunlight or stuff like that can affect the color that it has. So strength now. And strength refers to the timber's ability to resist and withstand the different types of external forces, aka the timber's ability to carry various loads. So this property is due to the abundance of interlocked fibers to provide strength. And the strength of wood is determined with reference to the direction of the grain of the wood under load. So we spoke about grain direction, and now we can see that grain direction also affects the strength of wood. So there's specific factors that affect strength. We're going to focus on a few of them, not all of them, but some key ones are density. And density speaks to the makeup of the mass per unit volume involving trees. So that's I use the formula for density, but the makeup are the amount of substances, the amount of substance in the tree per unit volume. So per each volume of tree, so of the tree. So in other words, how thick or how thin or how compact that the makeup of that tree is. So it says that the higher the density of the timber, the greater its strength will be. So the thicker it is, the more dense it is, the greater, the stronger it will be. And this is because high density of timber is a result of thicker cell walls. So thicker cell walls mean denser tree. Denser tree means greater strength. And that is a greater amount of wood substance per unit volume. Yes, same thing. A greater amount of wood per unit volume. Next, you have moisture content, and as moisture content may sound, it's amount of moisture involved in it. So you talk about the amount of water inside the tree, amount of water the tree carries or holds. And it says that the higher the moisture content, the lower the strength of the timber is. So it does the opposite of density. And this is because water in itself has no load bearing capacity. So if you realize that water, you can't walk on water, you can't throw a stone on water and it floats. You get me? Except if you're Jesus. If you're Jesus, then definitely that comes at no breeze. But in this lesson, just focusing on moisture content, that water has no load bearing capacity. That's why it's saying that it cannot bear load. So you may ask, not sidetracking, but you may ask, how do ships float? Some of you guys know this already, but there is air in the base of the ship. And because of that, coupled with the fact that the base of the ship is also kind of shaped to allow it to displace itself on top of the water, that's how you keep it afloat. Quick example, you have a dish, a plastic plate rather, and you have a sink full of water, and you place the plastic plate on top of the water. What it does, it floats. That's because the bottom of the plate is flat and there's air in it to balance out. But if you push your hand in it, or you make water start to go in there, you bore a hole in the plate, you realize it begins to sink because water is now getting in. So yes, similarly. So moisture content, water has no load bearing capacity. So it cannot carry load. So the more water in the tree is, the lower the strength of that tree is. And the presence of defects. And defects, when we talk about defects, you have natural and artificial defects. So we talk about cross grains, knots, shakes, twists, warps, cupping. So like these are different defects, are different things that abnormalities or anomalies in the tree or the lumber or the timber itself. And because of the presence of them, they can decrease the strength of the tree or of the timber. And we spoke about density as a factor, but it also is a characteristic. So density is the mass of wood substance and the moisture enclosed within a piece of wood expressed in kilogram per cubic meter. So that speaks a lot of physics or wood calculation. But in long short, as we said earlier, the heavier timbers tend to have a high density and lighter timbers tend to have low densities. Durability now. Durability speaks to the resistance of tree timber to fungal decay of the heartwood of the species. And that's just a really big way of saying the timber's ability to withstand diseases or insects. And when you think about insects, you can think about termites that feast on trees and timber and wood. And when you think about diseases, you have things like yellowing. Well, we had an outbreak of that in Jamaica that affected quite a number of coconut trees across the island, especially in the St. Thomas region, and other diseases. So, if the coconut trees were able to withstand um, the yellowing disease, then it would have been seen as durable. Understand? So any timber that is has the ability to withstand various diseases and insects would be deemed as durable. And inside the cell walls during growth are chemical substances inserted, such as oils and resins, that cause the timber to be or become more durable. So just like how for us when we're growing, we get that injection of, well, immunization. We get immunized and we're given certain, it might sound really, really scary, but like tuberculosis or TB, which is a very, very dangerous and and what's the word? When you can spread, when something is easily spread, I can't remember the word, but or contractable disease, easily contractable disease. We were injected with a small dosage in our bodies when we were babies, so that while we grow, our body immune system develops the immunity to it. Similarly, the trees are injected with oils and resins that as they grow, they gain the durability to resist these diseases and such. A suitable preservative inserted in wood can increase durability. So, and here we have just the references where you can go and access this information that I share with you guys. Um, Thank you for listening. This was just a review of the lesson, but you can go through it, um, which was for class itself. But thank you so much for listening, and we wish you all the best on your exams, the tests, and go do well. Alright, guys.